got to be doing your homework, kids. Good news today, no graphing on your homework. That's good news, kids. Oh my gosh, Sam.
First time I'm with you in a big pencil. Oh, it's the second, actually.
Guess what? I gave a pencil to a girl last hour, and I didn't even get a match.
Because I remember one time I asked you, how did you have that weird one? She's like, oh, I just someone like that.
I see you with the laser, I'm going to know. Unless you sharpen it down. But it says, Gene Harrison, personalized tutoring and piano lessons. Because for some reason in kindergarten, for presidents, like on Abe Lincoln's birthday, they made an Abe Lincoln magic wand, and they used a big giant pencil. And then on George Washington's birthday, they made a George Washington magic wand on these big giant pencils. And then I just asked Parker if I could have these big giant pencils. And he said I had to keep this on here. And he told me that about Abe Lincoln too, but then he fell off. So I have a George Washington. Very rosy cheeks. They're magic wands. I don't know why Abe Lincoln and George Washington become magic wands, but they do. In kindergarten. There's an electric pencil sharpener back there. Today we're going to talk about inverse trig functions, which we've already done in our calculators. Part of your homework today is just doing inverse trig functions on your calculators, which is really, like, you've been doing it. You just type it in and you get the number, and it's amazing. But we're also going to focus on doing stuff without a calculator, and that's going to be the quiz this week, is the without a calculator stuff. And the reason we don't have to graph today is because these are really used for solving equations. There are graphs for inverse trig functions. We're going to look at them today, but you do not have to graph any on your homework today. Like, your homework will fit on one side of a paper today, which I use a lot of paper, and mine fit, like, on one side. Like, no work, really. It was so exciting. But there's some background knowledge here. So you don't really have to write this page, like this page of notes down. You're welcome to, but you don't have to write this down. This is kind of just why this is true. Back in chapter 2, that was a really long time ago, but in chapter 2, we talked about how you can tell if a function has an inverse. And if a function has an inverse, it has to pass the horizontal line test. Do you remember, like, x squared? If you graph x squared, does it pass the horizontal line test? It fails, which is why the inverse of x squared is restricted, right? Because if you graph the inverse of x squared, it looks like this. That's not a function. It fails the vertical line test, which is why we only take half of it. We always look at, like, y equals the square root of x, like the top half, or we look at y equals negative the square root of x, which is the bottom half, right? We restrict the domain so that we can make it have an inverse. All of the trig functions are going to fail the horizontal line test. Do you agree with me? Because all the trig functions repeat themselves. They're periodic. So they all fail the horizontal line test. So that's what I wrote here. But it fails. But there's rules. Just like this, we can restrict the domain to make it have an inverse. And there's rules of where do you restrict it. So I'm going to give you these rules. You don't have to write these down. It's not going to show up on a test. I just want to show you where it comes from, because sometimes I feel like if people just throw things at you, you're like, I don't understand why that's true. So here's what we're going to do. What if we only looked at sine from negative pi halves to pi halves? That would be like from right here to right here. Oh no, I have very exciting news. The rest of Breaking Bad showed up on Netflix yesterday. I know. Bryce isn't here today, I think because he's home watching. I wanted to, like, power through it last night, but it wasn't happening. My husband started throwing up, and he has stomach flu now, so it didn't happen. We watched zero. It went through the entire family. Better news, I took my son back to daycare today, and they informed me that people are getting it for a second time. So I thought once we all had it that we would be, immune to it, but they're like, a teacher and a student have already had it for a second time, so I'm looking forward to the second bout of the stomach flu. So not very happy about that. But anyway, I'm excited to watch it, because we only had one episode left of the old stuff. Like we were almost caught up, and so we were kind of like saving it because we didn't want to watch it and then not get the new episodes. And I know Bryce has skipped school today just to watch it. I know we did, Trevor. You text him later and tell him I know so. I almost sent him a Remind 101 because I could send just to him. And then decided just to stay home. So, from just be this little chunk of the graph, yes? And there's certain rules that have to happen for this to be able to say it has an inverse. And one of them, and again, you want to write this down, is that it has to be either always increasing or always decreasing. There's a special like math word that I don't think ever shows up anywhere else besides math, but we say that this means it's monotonic. And they asked me in second hour if this was going to be a fill in the blank on a test, and I promise you it's not. Not even going to be a bonus on a test. It's just a word I like to throw out there every now and again to show you that it's a special word. Maybe someday on Jeopardy, you'll be on Jeopardy and this will be a question and you'll win because you know the word monotonic. But it just has to be always increasing or decreasing, and this one is always increasing, so check mark. What else has to be true? It has to cover all the values for sine, and it does. Sine goes from -1 to 1, and from here, that's from -1 to 1, so it covers all those. And then the third thing that we already knew had to be true is it has to be 1 to 1, which means it has to pass both the vertical line test and the horizontal line test, and it does. So all of the trig functions will have an inverse, but they'll only have it on a restricted domain. And this is the part that we have to know. Okay, and so today we're just going to practice evaluating this, but I'm going to spend a little bit more time kind of showing you where this comes from, talking about remembering what it means to be an inverse, that the domain and the range switch, so it's kind of like a different mindset when you're doing it. But overall, the idea today isn't bad, except you have to know your unit circle values or your special triangles, which some of us still don't know. So that's the hard part of it, I guess. So next slide, I want you to write this down. Write this down. So because that's true, it meets all those values, then we can say on the restricted domain from -pi-halves to pi-halves that sine of x will have an inverse. And up until this point, we've only written it like this because that's what our calculator button says, inverse sine. But this means the same thing. Arc sine of x. Arc sine's too big to fit on the calculator, so that's why they do sine of -1. But those mean the same thing. Your book will use them interchangeably. I will use them interchangeably. And it really means the angle, or arc, that's where arc sine comes from, whose sine is x. And I think sometimes the hardest part about this is knowing what the question's asking. And that's the big thing that you have to think about what it means to be an inverse. And so I just thought we could compare the function y equals sine of x to the function y equals arc sine of x. Or you could say sine inverse of x. They mean the same thing, so it doesn't matter which way you write that. Isn't it weird to write with that giant pencil? It like throws off your like center of gravity or something. Oh, that's good then. Maybe you need that big giant pencil. I know. I like that pencil, but maybe you could borrow it anyway. And then soon we're gonna sharpen it enough, and it won't be a big giant pencil anymore. No, because then you'll just keep sharpening it until I give it to you. So this is what we've been doing. When we do something like this, what do we plug in for x, or what do we pick for x? Stuff on the unit circle, like angles, right? Like pi fourths, pi thirds. So we plug in angles. So the domain are like values on our unit circle. And the output, the y value, I'm going to say we get out actual values, like 1/2, square root of 3/2, or just some random number, 0.76. But the domain is the angles, the y value, the range is the value. Just think about our graphs. The x-axis is always angles, the y-axis is like 1, 2, 3. If we take the inverse, if we we switch those around, then our x and y values are switching. So now, when you're doing the inverse sign, which would be the same for both of these, I'll make this a little bit longer, we're going to plug in values. So now our x values are like the output, and we're going to get out angles. Because that's the definition of an inverse, that the domain and range are switching. So now my y values are angles, and my x values are the actual values. Make a little bit of sense? Do you believe me on that? Maybe? So I think we're going to write this one more way, maybe? A lot of writing today. Second hour, they said they would trade off the writing for the no graphing on the homework. So it's the only day I've heard people be happy about writing. Can I go? Okay, so one more thing here. This is kind of like the definition now. Inverse sine function. So it says y equals arc sine of x if and only if sine of y equals x. And again, it's like you're switching it back from inverse sine to not sine, so the y and x switch. Someone in, who was it? Philip. Philip always thinks of things very complexly, I feel. Complexly? I don't know if that's a word. He said to him, he thought about logarithms here. Remember when you used to do logarithms and you would change it to exponential form and you'd switch it around? He said that's what he thought of when he was doing this, because you change it from arc sine back to sine and you switch the x and the y. I don't know. I've never thought of it that way, but I said you could think of it that way, I guess. But here's the important stuff. The domain and the range are very restricted, right? In arc sine, the domain is now the output. So your domain is your negative 1 to 1. And your y values are always restricted between negative pi halves and pi halves, which means the only answers you can give me are between negative pi halves and pi halves, which means you can never give me an answer of pi. You can never give me an answer of 5 pi 6, because it's not in that restricted part of the graph where it's monotonic, where it's 1 to 1, and where it has all the values. So for me, when I'm thinking of this, we're about to do some problems here, I think about, like, if I graph sine, like on that first page, I think about all my answers are stuck between negative pi halves and pi halves. So like negative pi fourths and 0 and pi fourths and pi sixths. Like, those are the only answers that you can give me, is what's stuck in between there. Okay? So what kind of questions could I give you with this? These are like all the problems on your homework today. Half of them are without a calculator, like these problems, and then the other half are with a calculator. So, Colton, put your calculator down. These are without a calculator. What you have to know is what this is saying. And this is just like saying the sine of what angle equals 0, right? This is like the answer. The sine of something equals 0. You have to give me the angle that that's true for. So step 1 is you got to know what that's asking. Step 2, you got to know that your answers are stuck between negative pi halves and pi halves. So you're only going to have one answer that fits in that interval. Step 3, you got to know your trig values. Where does sine equal 0? On the x-axis. So where does sine equal 0 between negative pi halves and pi halves? And is that true? Does the sine of 0 equal 0? That's true. Okay. No, the cosine of pi halves is 0, but the sine of pi halves is 1, right? Because pi halves is up on the y-axis. So if you're up here, that's 0, 1, sine is y. Oh, well, this is graph, right? So like this is if I graph sine, it would be like this side goes up, this side goes So the sine of pi halves, this one. What about this one? Second arrow, they said, oh man, it's getting really hard now. But it's not getting really hard. It's just a different angle besides 0, a different value, right? Negative square root of 2 over 2 is in our unit circle. So this is still a no calculator problem. On your quiz that you're going to have on Thursday, it's all no calculator, which means it's all problems like this. And again, you don't have to write this out every time, but this is what you should be thinking. When I see inverse sine of negative square root of 2 over 2, I'm thinking in my head, the sine of some angle has a sine of negative square root of 2 over 2. No calculator, Nick.
Why isn't it on the bottom? Why isn't it negative? Like negative sign.
Oh, down here? Because I'm going backwards, right? Like, if it says inverse sine of this, it's the same as thinking the sine of something equals negative square root of 2 over 2. You see what I'm saying? Like, using this up here. If this says y equals arc sine of negative square root of 2 over 2, that's the same as saying the sine of what, or the sine of y equals negative square root of 2 over 2. You see what I'm saying? Like, it helps me to rewrite it like this to think about it, because we should be able to say the sine of what angle equals this value. Does that make sense of why I wrote it like that? You don't have to rewrite it like that. I hope at some point you just look at this and this is what's kind of going on in your head. But your answer is supposed to be an angle. So that's why I rewrite it like this, to try to help you think about the sine of something equals this. That something is your answer. Sam. You can guess it or be confident in it. I want radians first of all. 7 pi fourths, I think you mean. 7 pi fourths does have a sign of negative square root of 2 over 2. But is 7 pi fourths in between negative pi halves and pi halves? See what I'm saying? So that's the tricky part of this. The tricky part is you have to make sure your answer is between negative pi halves and pi halves. So instead of giving me that positive angle, you're right, it's down here in quadrant 4, but go backwards. Colton? Yeah. So instead of 7 pi fourths, you have to go backwards, and the answer that I want is negative pi fourths. Does that make sense? And that's the part that you have to know this. Okay? If you say 7 pi fourths, you're right, that's true, but it doesn't meet the requirements of the inverse. Now, the second hour, they said, wait a minute, this is not on our unit circle. How can we do this without a calculator? Colton, put your calculator down! Goodness, how many times do I have to tell you? I'm going to throw it, only it's mine, I think, so I'm going to throw my own calculator. And I said, I know this is not on your unit circle, but this still could show up on a no calculator part of your test, because this is like saying the sine, if you don't want a question mark there, you can put like the sine of what equals 2.5, and you should be able to tell me that there's a problem here, because can sine, if you want to domain here, can sine be 2.5? It can't. There's no angle whose sine is bigger than 1 or smaller than negative 1. So I should be able to put this on your no calculated part of your test, and you should be able to tell me that this is undefined. It's not in the domain. You can't do it. And of course your calculator is going to tell you that it's undefined. And so they decided in the second hour that if there's anything on the no calculated part of the test that's not from the unit circle, they're just going to know to put undefined, because it has to be undefined, right? That's true. This is really all your homework today, but it's not just sine. So we have to talk about arc cosine and arc tangent as well. I want to look at the graph of arc sine. You do not have to graph on your homework. You're never going to have to make these graphs. I don't think it's a bad idea to sketch it on your notes so you have it. but it's never going to be required on your homework. I just think it's good so you can see why it's so restricted, because the graph of the inverse is very restricted. And we're only going to do arc sine, and then the other ones I'm just going to show you, so if you want to sketch them, but we are actually going to graph arc sine together.
Okay, but negative pi halves thing, how do you make that just like negative pi halves, would that just be like 207 basically?
It would, but you have to go negatively. That's why I don't think about the unit circle when I'm doing this. I think about when you graph sine, right? Like, let's go back to my graph here. I'll say when you graph sine, do you agree that this is negative pi halves and this is pi halves? And so think about your answers can only be those in between. And so negative pi halves, this will be negative pi fourths, 0, pi fourths. If you want to think about the unit circle, you're right. It's like from here to here, but you can't think about it in terms of positive angles down here. Like, you're right. This is the same as 3 pi halves. There's a 7 pi fourths over here. There's an 11 pi sixths over here. But you can't think about it like that because you have to think about it in terms of it has to cross 0. Like, it has to go from negative pi halves to 0 to pi halves. It's not going from 3 pi halves backwards to pi halves. I don't know if that makes any sense or not. It's kind of a weird thing to think about. But like, that's why I think about it in terms of this. Like, I always think about my graph, and I think about I have to cross 0 from negative pi halves to pi halves. No, yes. It's why the interval is so important. I mean, there was one on your worksheet that I gave you that you had to give me the answer between like 3 pi and 4 pi. Do you remember that one? Like on the back page of the worksheet? Like, I could ask you an interval from anywhere, and it just depends on how you want to add or subtract pi or think of positive or negative. But you have to go in order from negative pi halves to pi halves in order to get those rules. Like, that's why that it's important that you go like that. And then let's look at the graph and see if it makes any more sense or not. It becomes one of those things that you just have to end up memorizing, but I'm hoping that maybe the graph of this, that's why I would show you the graph. I mean, the graphs never show up on homework. It's never going to show up on a test, but I feel like the graph helps maybe solidify this a little bit. I think it's weird to graph arc sine of x, so I want to think about if we graphed y equals sine of x and picking those points. And then if you remember anything about inverses, then we should be able to translate that to arc sine of x. And again, this is the only one we're actually going to pick points for, and then the other ones I'm just going to show you because you're going to see it's kind of the same idea. I know I'm restricted already, so I'm going to make my x values go from negative pi halves to positive pi halves. There's no use in picking points outside of that because I know it's not in my range. So I'm going to do just like we did before. I'm going to pick halfway in between that to get 0. Halfway in between that to get negative pi fourths, positive pi fourths. And again, this is something that you should know these values. I'm just plugging them into sine. If I plug in negative pi halves, I'm on the y-axis down at the bottom. So y is negative 1 there. Negative pi fourths is the same as 7 pi fourths, which is negative square root of 2 over 2. Or I think that's about negative 0.7071. Sine of 0 is 0. Sine of pi fourths is just the positive that, 0.7071. And pi halves has a sine of 1. That's how we get those lovely little curves that we get on sine. If arc sine is the inverse of sine, what do I do with my xy chart? You flip it. Definition of inverse, the x and the y switch places, the domain and the range switch places. So now, maybe it kind of helps to see this, the y values become your angles. So your y values are negative pi halves, negative pi fourths, 0, pi fourths, and pi halves. And your x values are your outputs, your values. Negative 1, negative 0.7071, 0, 0.7071, and 1. And so it's kind of weird to graph these, but it's always going to be this graph. My x-axis is now only from negative 1 to 1, which is why if I asked you to find the arc sine 2.5, It's undefined. There's no value there. It stops at 1. And my y values are now my angles. So this is going to go from negative pi halves to pi halves. Halfway in between that would be pi fourths and negative pi fourths. So at negative 1, it's negative pi halves. Negative 0.7071, that's almost 3/4 of the way, right? So that's, I'm going to say it's roughly about right there. Would be negative pi fourths. At 0, I still get 0. At 0.7071, I get pi fourths. It's a little bit more than that, but that's okay. And at 1, I get pi halves. Unlike sine and cosine and tangent, there are no arrows on the inverse trig functions. Like, they stop. Those are dots, which is why I don't make you graph these, because that's it. Like, there's no translations, there's no shifts, there's no amplitude change. Like, this is the one graph. And your answers can only be restricted on those exact values. Because if we graphed any more of this, it would fail the vertical line test. That's why we're so restricted on our answers. It's also why we give the negative angles and we don't do like 3 pi halves, because 3 pi halves would end up being over here, and then we would have issues with passing the vertical line test. Okay? I don't know if that helps any or not, but that's why I give you that. Same thing is true for cosine and tangent. They have an inverse, but they're restricted. Where they're restricted is not necessarily the same as where they're restricted for sine. So the part that you have to learn and memorize is what are my restricted values. And so I spent a lot of time on sine to kind of give you the background of it, and then cosine and tangent I'm just going to kind of summarize for you. Again, it's up to you if you want to sketch these graphs down that I'm going to show you. They're in your book. I don't care. You don't have to sketch them. It's your prerogative. But for cosine of x, where does it meet the requirements? And it's again up to you if you want to write all this down, but I'm going to summarize for you in a minute. Cosine of x is decreasing in 1 to 1 on the interval from 0 to pi. So if we graph inverse cosine, it looks something like this. And your answers are only from 0 to pi. And it kind of just looks like that. It's the only place where it meets those requirements. And so if you're trying to, figure out a shorthand to write here, I would say write this and say from 0 to pi if you don't want to write everything down. If you want to write everything down, you can. And so again, that's the hard part, is remembering that your answers for inverse cosine can only be from 0 to pi. And in a minute, we're going to make a little chart to write them all down. We don't do a whole lot with the inverse reciprocal functions, like inverse cotangent, inverse cosecant, inverse secant, but we could. Their restricted parts are the same parts as cosine. Like inverse secant is the same as inverse cosine. Inverse tangent is the same as inverse cotangent. Inverse sine is the same as inverse cosecant. But I don't think your book gives you any of those. Like I think they only give you sine, cosine, tangent. Which means that's all I would give you. And did you notice we skipped 4-6? Skip 4-6. On purpose. It's kind of a cool section if you want to go back and look at it. It's graphing composite trig functions. So graphing like sine plus cosine, sine plus tangent. These are some crazy graphs. They're not really something that we spend a lot of time on, so I skipped it to save you some nightmares. Yeah, there's no inverse trig on your, or no reciprocal trig. Can I go? Same thing for inverse tangent. This is the graph of inverse tangent of x. Notice that tangent is like that S shape, so notice we've just turned that S shape on its side, and it's just one little S, because after that, if we graphed more than one of them, it would fail the vertical line test. That's where two asymptotes are. So those vertical asymptotes have turned into horizontal asymptotes. And again, if you're trying to shorthand this, I would just just write the bottom part here. Notice that inverse tangent is restricted the same way that inverse sine is. They're both negative pi halves to pi halves. Inverse cosine is the only one that's different. Your entire homework problems today are just finding the values big thing you have to know is just where they're restricted and how to give your answers and how to do this without a calculator. Obviously, I can't yell at you every time you pick up a calculator at home the way I yell at Colton in class, which means if you use your calculator on the homework, I can't stop you, but I'm telling you that we're going to have a quiz on Thursday without a calculator, and your test is going to be half without a calculator, and so if you're using your calculator on every problem of your homework and not thinking about the unit circle or your triangles or however you think about it, you're not preparing yourself for the quiz and the tests that count for a good amount of your grade. So just keep that in mind. Maybe I'll send out random Remind 101s tonight. Put down your calculator. Can I go? Not go? So we're going to write this out like all together so you can have like the go-to place in your notes for this, and then we're going to do a few problems, and then I'm done. Yes?
So on the quiz on Thursday, is it just over like this lesson and on, or is it from?
It's going to be mostly this. Tomorrow we'll talk about it, but there's going to be 2 graphs on there. Just some basic graphs that I want to see that you have any clue how to graph at this point, since we're going to have a real test next week. And I haven't really, like, we had a homework quiz where you're copying graphs from your homework, but I want to see where we are on graphing. And so we'll kind of talk about that briefly tomorrow. But I think it's 20 points, and I think like the majority of it is this, like, do you know how to do this? And then like 2 graphs at the bottom. So maybe I'll even tell you an idea of what to study for your graphs, but probably one with asymptotes and then one without asymptotes. So like 1 sine or cosine and then 1 asymptote one. So, but yes, that's what it is. So here we go. We're going to write the domain and the range for all these. And really, if you have this, this is what you need for your homework. You might say, why didn't you just tell me that to begin with? Because I like to try to explain where this stuff comes from instead of just throwing random things at you and saying do it. And again, you can write those with the -1. They mean the same thing. I don't know. I tend to like the arc in front of it. I don't know why. Remember, domain and range are switched now. So when we're talking about the inverse trig functions, the domain for sine and cosine are the outputs, which the domains are going to be -1 to 1 on both of those, because think about sine and cosine are stuck between -1 and 1. The range is the part that you really have to know, because that's the part that you have to give your answers between. And so sine, arc sine, is between -pi-halves and pi-halves, and I promise the more that you do it, the better that you'll get at giving me those negative angles. It's weird at first because we don't do a lot with negative angles. Arc cosine, if you remember the interval, it's easy because there's no negative angles. It's from 0 to pi, which means you're in quadrant 1 to quadrant 2, so the whole top half of your unit circle. Arctangent is the same as arcsine, -pi-halves to pi-halves. What's the domain of arctangent going to be? Like when you graph regular tangent, what's the range of regular tangent? What does regular tangent look like? So what would the range of that be? Is the domain of this going to be all real numbers when you turn that on its side? And those are actually going to keep going forever. So the domain of this one is all real numbers, because tangent can be anything, unlike sine and cosine. If you know that, and you know your unit circle values, little asterisk beside that one, then you can do these. And so your homework today is going to look like stuff like this, just between sine, arcsine, arcsine, cosine, and arctangent. And then you have to just think about in your head, and it's up to you on how much work you show on this. If you have a unit circle that you're looking at, you might not have to show any work on these. Colton, make me take that calculator out of your hand. You should be thinking 2 things when you do this. Thing 1 is, what is the interval? You have to know arctangent, your answer can only be between negative pi halves and pi halves. So don't give me an answer outside that interval. I see you, Colton. The second thing is you have to understand what this is asking, and that's the part that you can write down or not write down. But you have to be saying, when it says for the arctangent of the square root of 3, that's asking me, where does tangent equal the square root of 3? What angle has a tangent of the square root of 3? And that's where you have to know your unit circle or you have to know your triangles. I know most of you are on the unit circle board, and I'm okay with that. But just to show you, when I do this, I'm really a triangle person, and I know that the square root of 3 is in that 30, 60, 90 triangle. You should be able to know that we're either talking about pi 6 or pi thirds, and if you're unit circle, just think about it. But this is where I'm a triangle person. I draw in pi 6, and I say my triangle is 1, 2, square root of 3, and I think about the tangent of that. The tangent of that would be 1 over the square root of 3. That's not true, which means I don't even have to check it, but since I'm showing you, I know it has to be up here at pi thirds, because that would be square root of 3 over 1, and I know my answer is pi thirds. That's how I use triangles, those special triangles. If you're a unit circle person, you're doing the same thing, but I'm telling you, people for some reason mix up tangent all the time with the unit circle. But if you're a unit circle person, then this is square root of 3 over 2, 1/2, and this is 1/2 square root of 3 over 2. Don't forget that tangent is y over x, because I think tangent's the one that's mixed up the most. So y over x would give me square root of 3 over 1 up here. This would give me 1 over the square root of 3, which was why it has to be pi thirds. Yes? Brain work more than paperwork, more than calculator work as well. Will your calculator give you that answer? If you're in degree mode, definitely it'll give you an answer of 60 degrees. If you're in radian mode, it will give you an answer of pi thirds in radians, which I don't think most of you know that in radians unless you have one of those fancy calculators. I don't even think it'll give you pi thirds, though. Someone check and see. But it doesn't matter, because on the test and the quiz, you don't get a calculator on those parts, which means you should be trying to do these without a calculator, and then if you want to check with the calculator, then you can check. Let's do another one. Because really, on your paper, all you gotta do is write pi thirds. Like, that's the answer. Which is why technically on your homework tonight, like, you could write number 1 and an answer, number 2 and an answer. Like, you don't even need space in between if you know your values. Again, what am I thinking when I see this problem? Step 1, I'm thinking my interval. What's the interval for arc cosine? I just wrote it down. 0 to pi, which means don't give me an answer that's not between 0 and pi. And then I'm thinking, this is like saying the cosine of what equals negative 1/2. Which means if I'm between 0 and pi, and my cosine is negative, what quadrant do I have to be in? Quadrant 2, don't give me an answer in quadrant 1, because cosine's not negative in quadrant 1. And if I know anything, I know that cosine negative 1/2 has to be like 2 pi thirds or 5 pi 6, right? That's the only one that has a negative 1/2 in it. Can't be the middle one. Yes? You got to know these things. And so if you're down to that, you got a 50-50 guess. Hopefully you know. Again, I'm a triangle person, but I'll do my values here. You know without me doing this? This is negative square root of 3 over 2, 1/2. This is negative 1/2 square root of 3 over 2. You should be able to do that at this point in your pre-calculus life, being able to get those values. If you don't know those values, we're in a lot of trouble. Right? All that stuff from chapter 4, part 1, still very, very important. Inverse cosine of 1. cosine of what angle equals 1? Zero. We should have like a time test for this. That will be the real test. Do we know our values? You should be able to know those things. Like you've got to be able to think cosine is x. Where does x equal 1? 0. Done. Without typing in your calculator. You should be able to give me that answer faster than typing in your calculator. Number one thing you should be studying. Number one thing you should be doing besides your homework is studying those values and knowing those values. The only other thing on your homework, I think there's 20 problems on your homework today. 12 of them are this. Like those exact thing, all the different values on your circle. And then 13 through 20 are doing the same thing with your calculator, which is just practicing using your calculator. Super great thing is I'm pretty sure your calculator always gives you the answer in the right, like that's why sometimes when we did this in the last section, it gave you a negative answer because it gave you the answer from negative pi halves to pi halves. But I think you just type this in your calculator in radian mode and you just get the answer. 8 of those on your homework today. How much easier to get? Remember that the arc cosine is the same as cosine negative 1. If you're not in radian mode, you're going to get the wrong answer. If the directions, I think some of the directions today say do in degrees, so make sure you do the mode that they say, but I like radian mode. But I think if I do this, I get 2.3462 radians. Is that between 0 and pi? Yep, it is. Inverse sine, 0.31, I get 0.3152. If you don't get those answers, you should see me so I can help you use your calculator right. If you don't type this in your calculator during class and then you miss it on a test, I can't help you if you're not telling me that you're having trouble doing this. Inverse, like sine negative 1, cosine negative 1. Right, arc is the same as inverse cosine. Just another way of writing it. 1 through 20, exactly what we've been doing. And I'm telling you, 13 through 20 are just using your calculator. 1 through 12 is without a calculator. That's the kind of stuff you're going to expect to see on your quiz on Thursday. And then 59 and 60 are multiple choice, which you also could do without a calculator. Alright, tomorrow we're going to add a little bit more to this, but this is the stuff that's going to be on your quiz besides graphing. Tomorrow's assignment will not be on your quiz, but it's just kind of going a little bit further with it, like doing some algebra, looking at some properties of this, but it's not so bad. And then we only have 4-8, which we will do on Friday. And we're doing 1 day of 4-8, which is story problems, which means we're going to review Monday, maybe Tuesday. We'll see if we do 2 days review or not. Definitely test no later than Wednesday of next week. It's either going to be Tuesday, Wednesday test or Wednesday, Thursday test next week. So that means all of your homework is due